This is the presentation of my project for the machine learning course, Not So Random Composer using boosted neural networks. So this project has evolved from a previous project that's called Random Composer using Mathematica that I built earlier. And now using some machine learning techniques, I want to build a not so random composer. And now let's see how. We start with the question, why not so random? And the assumption is that a sequence of G nodes determines the G plus first node. So we have the features and we have the target here. In this project, I assume G equal to 3. So we have the 3 nodes x1, x2, x3, and they are vector quantities with components node value, octave value, and time value. These constitute 9 natural features. On top of that, we are going to engineer some features. So first we have the distance between pairs of nodes and the fact that, or whether this node is in key, or this node is in key, or this node is in key. And we have a direction, whether we are ascending or descending as we approach the target. And finally, whether this pair, or this pair is consonant or not. In total, we arrive at 21 features, so now let's focus on the target. It is again a vector quantity with the components node value, octave value, and time value, and we assume them to be independent. We have this recursive model, the model for boosted neural networks with the neural network unit function here. And we are going to assume some value for m later. For the cost function, we use a multi-class softmax cost for each of the targets. We have 3 targets, we have 3 cost functions, and we are going to optimize them separately. In the cost function, we have this term that indicates the weight. So in the training data, we have Chopin's nocturnes, and we have this sample data introduced by the user. We use a weight of 1 for the nocturnes, and we use 10 for the sample data to enhance the user characteristics in composition style. And we optimize our cost function using a gradient descent approach with a fixed learning rate of alpha equal to 0.01. We assume 30 rounds, and for each round we have 1000 iterations. Now we have this sample composition that is used in the training. We need to generate some music on top of that. So how do we do that? Once we have the optimized ways, we obtain the z-scores, and then we are going to use them in the probabilistic approach to determine the classes with certain probabilities, and we are going to pick 2 most probable classes for the node, octave value, and the time value. And generating one node after another, the computer will arrive at such a score. So this is a sample composition completed by the computer in the style of Chopin. And this package, this code is publicly available at the given link. And with that, we end this presentation. Thank you.